Hello everyone, and welcome to this video on the least squares regression line. In the previous videos on bivariate data, we mentioned the lines of best fit that are used to model a linear relationship between two variables. The least square regression line is one of the many types of best fit lines. Today, we will start with the definition of the least square regression line. Then, we will explore the equation of the line, and we will finish off with some reminders. In this graph, we use y hat n to represent the y values predicted by the best fit line corresponding to xn. Meanwhile, yn is the actual observed y values at the corresponding xn. In the case of the least squares regression line, it is a line that minimizes the sum of the squared difference between the predicted and observed y values. In another word, the least squares regression line is essentially a line that allows the smallest value of this mathematical expression down below. From the definition, it is intuitive that the best fit line passes through the point x bar, y bar, where the x bar and y bar are the respective means of the x and y variables. In order to determine the equation of the line, we locate another point on the line, x, y hat. Since the slope is right over wrong, we subtract the coordinates and divide the difference. Rearranging, we now have determined the skeleton equation of the least squares regression line. On the other hand, the slope is also equal to r times the quotient of the standard deviation of the y variable divided by the standard deviation of x value. Combining these two, we can now find the equation by plugging in the information about the data. Last but not least, I have some reminders regarding the best fit line before we finish our discussion here. Firstly, please do not force a best fit line if the scatter plot indicates a nonlinear relationship, because the best fit line would not apply well in this situation. Next, not all data follow the direction of the overall pattern. For example, a set of data might exhibit a negative overall pattern, but there exists one point, or some points, that are greater than its previous ones. Thirdly, even if a best fit line can describe a variation very well, the pattern might not sustain beyond a certain value. Thus, we should be very careful with extrapolations using the equation. In the end, let's recap. Today we started by defining the least squares regression line, and moved on to determining a skeleton equation. After that, we gave some reminders about the application of the best fit line. I hope you enjoy learning with me in this video, and see you soon.